Welcome to the Rich Report, a podcast with news and information on high-performance computing. Today, my guest is from Terascala. We have Bryan Cote. He is the Director of Product Management at the company. So, Bryan, welcome to the show today.
Hey, thanks, Rich.
Well, thanks for coming on, Bryan. What I thought we'd do is have you go through the slides, and then we'll do a Q&A at the end.
Oh, that's great. Yeah. So let me start off by introducing Terascala. Terascala is a company that's been around since about 2005. We're based in Boston, Massachusetts. We've got a lot of different investors, including companies like Intel, and we've been we started off life in 2005 manufacturing storage appliances based on Lustre. And, early on we discovered that, it's probably better if we partnered with guys like Dell rather than compete against them. So we've changed our model, and we now actually make a turnkey software appliance that these companies, and in particular Dell and NetApp, incorporate within their products to move forward and develop their own solutions that incorporate Lustre and create a high-performance storage appliance in a very straightforward and supportable fashion. So, we have a lot of different target markets. We've got, manufacturing, life sciences, oil and gas, number of customers in those verticals that you may be familiar with, companies like Westinghouse, Sandia, very popular in the university space with organizations or universities such as University of Minnesota and Florida State University. Typically high-performance storage is used in, product design, high-frequency trading, seismic processing, particularly in the oil and gas and energy space, as well as genomic analysis. A company some of your listeners may be familiar with, TGen, is doing a lot of research in the cancer space, and we back up their gene sequencers and help them innovate and develop remedies for different illnesses in record time. So, customers who typically look for a high-performance storage solution are companies that are really looking to shorten time to results. They have high-performance clusters, and they need to be able to accelerate or ingest data much more quickly than they can with typical enterprise-class storage. They want to avoid many points of failure. They want to have a single source, single solution that's supported by one particular manufacturer, or in this case, a couple like Dell or NetApp. They want to go ahead and optimize their workflows, and I'll talk a little bit about that with our ISB product, which is really going to be the topic I'm going to go into in some more detail. And they want something that's not a high-touch solution. Typically, customers who are using high-performance storage have an option to either roll their own, getting open-source software and building their own, or going to a single-source vendor and buying an appliance. And that's what we think is the trend that's going to be going forward in the years to come. The primary product we have is a product called TeraOS, and TeraOS is a single-image appliance for high-performance storage that incorporates a Lustre kernel. So your listeners may be familiar with Lustre. It's a parallel file system that's based on technology developed at NASA and the universities. We incorporate that with a operating system stack that's based on a popular kernel from Red Hat for Linux. We also apply some proprietary management and monitoring frameworks around that make it much more easier for the users to manage than typical roll-your-own solutions. Now, we bundle that TeraOS in the what they call the object storage servers, which are the two main components. You have your metadata and your object storage. Those two components form the basis of any TeraOS solution, and we call that the TPE. Now, customers can increase the performance capacity of their high-performance storage by adding a combination of hardware, additional servers, with the Terascala Performance Extension, which is a second bundling that we provide that allows users to add, typically 3 to 4 gigabytes a second of incremental performance onto their storage frameworks. And, what we've done is we've packaged this so OEMs who go ahead and create solutions for customers have a very easy way to start with a base solution and give their customers a way to move forward and add incremental capacity and performance as they wish. All of this, the software appliance is managed through what we call the TeraView user interface, which provides comprehensive usage analytics about the storage framework, how much is being used, how many different connections, are there any contentions in particular areas of the storage, what's the throughput we're getting, are there any failures. There's phone home capability that sends alerts back to the OEM, and users can subscribe to any number of different alerts depending on the severity. It really makes the typical Lustre deployment exercise a much more straightforward experience. Again, I talk about Lustre a lot, but really from Terascala as a company, our goal is to insulate the user from the complexities of the parallel file system as much as possible, and to really give them basically a straightforward appliance that they can use and get down to business without having to worry about all that technical booga-booga underneath. Another product that we have, and this is going to be the core of my subsequent slides, is the Intelligent Storage Bridge. Now, as the HPC market matures, there's been a transition from focusing on the speeds and feeds of the storage to how do I make sure I have the right data in the right place at the right time to maximize the efficiency of my expensive compute resources. Customers typically have to move the data from enterprise storage onto what people call fast scratch storage, and they do that by hand with copy commands or scripts, and those are limited and error prone, and what happens is when those things don't work as you expected, you have 5 hours of copying time that fail, you've got to start it over. Well, you've lost 5 hours of research on your cluster. How do you make that up? You can't get the time back. So we'll talk a little bit more in subsequent slides about the ISB. As I mentioned, we're an OEM. We provide technology to OEMs. We don't sell storage ourselves. Our two biggest customers are Dell and NetApp. Dell has a product called the DT-HSS, and NetApp has the HPS rack. Both of these are powered by storage offerings that come from each of the manufacturers. Dell uses some of their PowerEdge storage capabilities underneath, and HPS Rack uses their E-Series underneath. And both are configured slightly differently based on different customer market segments that they're focusing on. But at the core is the TerraOS software, which provides a consistent manageability and user experience. So the management of these solutions is almost identical. So let me talk about the ISB, and when I say ISB, I'm talking about a product which, I tend to use a shorthand internally, but we're talking about the Intelligent Storage Bridge. The Intelligent Storage Bridge was really meant to help solve a problem that we ran into with a number of customers who had large data sets that they were copying from typical enterprise storage onto this higher performance, scratch storage, which they'd run and do analytics. One of the customers talked about a use case where they'd kick off a copy job from enterprise storage to scratch that used to take, anywhere 5 to 6 hours. They'd usually do that before they left to go home at night. They come in the morning and find out that the job failed. Well, depending on where the job failed and how many files get copied, they had to restart it from the beginning, which meant that you lost another 5 hours during the day. And, if this happens more than once, you can see how it starts to add up and really translate to lost productivity, which, means lost, revenue and lost profits. So, we talked to them and said, how can we really help you address this problem? And that's where the idea of the ISB originally came from. So the ISB, really provides a couple of key value propositions. First of all, it's purpose-built for moving files as quickly as possible from point A to point B. And when I say files, I'm really talking about, things that are typically large sets. In the HPC space, we're talking about terabytes of data. Some of these files, we've had people that had, 20, 30, 40 terabyte files that they're doing analysis on. We really want to be able to get that from the enterprise storage where it typically sits, and then get it onto that scratch storage as fast as possible. And subsequently, once they've gone and done their analysis, they typically have terabytes worth of results they need to move back to enterprise storage for subsequent analysis, review, and publishing. So, the ISB handles the job of getting it onto that storage, getting it there, and getting it back. And also, it's typically the part of the organization that focuses on moving this data are the admins. It's these guys that have to, write scripts or kick the jobs off on behalf of the application users. The ISB puts that ability to copy from file systems, to mount those file systems, to move the data from point A to point B, taking out of the administrator's hands and moving it back to the researchers so they have more control, while offloading the admins to do, really what admins want to do, making sure the system's up and running. So, it's really focused on ease of use. It's GUI-based. I'll show a couple quick screenshots. And it's also the first product of its kind to be bundled as an appliance. And by appliance, I mean it's a combination of software and hardware that's designed to be highly available. It starts off with a minimum of 3 nodes. It's, N+1 redundancy. So you can go up to, right now there's only a theoretical limit of 100 nodes, but we've had test configurations in over a dozen different nodes to take advantage of the network fabric underneath. So if you think of each node has a 500 gigabyte per second throughput capability, you can really go ahead and add incremental as you need, depending on your environment, the amount of time you need, and how urgent your research is. As I mentioned, typically today it's done, on a workstation, copy command, move it from point A to point B, and, it could take up to 6 hours. Now, what the ISP does is lets you add in, takes the power of multiple nodes, load balancing, taking that workload, spreading it across multiple machines, and really takes it down from what would typically be, like 6 hours, can take it all the way down to 1 or minutes in the case of, certain jobs. So as I mentioned, the ISP is unique because, it's an appliance solution. It's something that's sourced from a vendor, from us in particular at this point, Terascala. It'll also be available through our OEMs in the coming months. It's highly available. In other words, if one unit fails, the workload is automatically picked up by the other units, and you don't miss a beat, and things keep going. So you don't run into that, machine failed in the middle of the night, I've got to come back in, restart the job. That's taken care of. It's designed to offload the administration, so administrators get to focus on uptime rather than, application and data workflow. Forms-based, no scripting experience necessary. You don't have to write Python or awk scripts or anything you need to, typically have to do. You just fill out a form, so almost, set it up like a regular job or a meeting recurrence in Outlook and kick it off, and it'll happen when it happens. It's monitored and integrated with TerraOS, so the users get a consistent interface that's integrated within the framework of the storage environment, so they don't have to learn different applications or different menus, and there's also a common access control method that's provided for the users within the context of the TerraOS framework. And as I mentioned, it scales through the addition of incremental modules. So if you can take a look, and I alluded to the recurring meeting appointment as a metaphor when we thought about how we were going to design the user interface. But it really is as simple as that. The user can go ahead and pick the source and destination file systems. The super user administrator within TerraOS really defines what users can see as far as file systems go. They set up essentially the pool of file systems that are available, so there is some control over who gets access to what. But the user can then, once they've selected the file system, can then select through a path, and they get a presentation of the files that are on that file system, and they can select which files within that file path that they want to incorporate within their job. Then they can trigger the job to happen, and the job can be, by the way, either a copy job, straight copy from point A to point B. There's also a copy from point A to point B, delete from point A if you want, and that's what we call a move job. And there's also a pure delete job. But whatever job you pick, it can be triggered by a couple of things. First of all, it can be scheduled on the next available slot, and by that I mean, because the ISB is doing the load balancing, it has a schedule that it adheres to, and it goes through and optimizes based on the available jobs when things get kicked off. So a user can say, go ahead and run this now, but what it's really doing is going ahead and scheduling in the first available slot once the other jobs have completed. They can also specify that the job is run by at a point in time in the future, so you can say any month, day, year, and at particular hours, minutes, and seconds, although seconds resolution isn't very helpful, but you can go ahead and you get the idea. And you can also trigger it based on the age of a file and the presence of a file. So, for example, in a case where you do use a script to copy, or a job is running, and at the end of a script or a job, it places a marker file like done.txt or something in the file system. That done.txt file can be used to trigger a particular job to then copy the files onto or off of fast scratch. So it's really done in a way that's very straightforward. As I talked about, there's a couple prime use cases. I talked about the one that's, just get data on there as quickly as possible and get it off as quickly as possible. We call that the data ingest and reingest use cases. There's also the case where I'm going to run a job multiple times. So I have my source data on Scratch, and I'm going to generate results, and I want to move the results off and put those onto, longer term or, enterprise storage again, because a lot of times in these simulation and modeling exercises, comparing the output of multiple runs is key to them understanding the dynamics of their design. But we also have the case, too, where users want to go ahead and push sets of data to multiple clusters. So they have 3 or 4 sequencers that they want to use to run against the job, and they're going to run these in parallel. So the ISB will let them copy one source of data to multiple sites and then consolidate those results back to a single enterprise storage for long-term support and archiving. Industries I mentioned, life sciences, they're ones who are a big fan of this solution. I mentioned companies like TGen who've basically come out and they've endorsed this, and they're one of our big early users who provide a lot of key feedback. Manufacturing, guys like Westinghouse are key users of this type of technology. In the oil and gas space, where they're often bringing large sets of data in off of ships, need to copy that into enterprise storage and then move it to Scratch storage for subsequent analysis. They're big fans of this type of solution as well. Again, a lot of times that the guys moving this data in and out of the systems aren't heavy technical users. They're just operator class users. This is a great solution for them to be able to move that data around. And I just have 2 quick slides here. We can just highlight them. So moving on to that, the first one, use case, is the one I talked about, optimizing the workflow. Again, a point I want to make is not only are we optimizing the workflow, but we're also optimizing the resource utilization. A lot of folks say, well, I've got this high-performance storage now that's complementing my enterprise storage, but do I need a separate backup solution for the high-performance storage? Well, why do you need 2 sets of backup hardware? The ISB allows you to take that data off of high-performance storage, move it back to enterprise storage, where you can go ahead and archive it using your existing tools and methodologies. So not only are you getting more utilization out of your compute farm, but you're also getting better utilization out of your storage resources and tools. And moving on to the next use case, this is the improved Scratch efficiency. That's talking about moving data in and out of multiple sources back to the cluster. The slide itself, folks who are just listening, not very helpful, but we've described the use case, so I'll just move on to I think it's my next to final slide here. It was my final slide. So if you have any other questions, I have contact information, and I think that covers the deck.
Well, great, Bryan. A quick question here about you were careful not to use the term hierarchical storage manager, or HSM, which of course is something that Lustre added in 2.5. Is that because the ISB is much more than that, or what would you say?
Well, it's different and it's complementary.
Yeah.
One of the things with the hierarchical storage that's in Lustre is you need a data mover component. So, one of the things that we're designing into the next release of the ISB is it will be a Lustre HSM compliant data mover. So we can take the instructions from the HSM component and actually do the heavy lifting on its behalf.
And then along those lines, Bryan, when you guys provide this, of course, Lustre is open source. Do they have the customers have hooks into that, or are you providing that as a kind of a higher level where they don't need to get in there?
Well, the idea is, and that's a good question. So we are going to provide the hook. So there will be, there's a couple things. We're going to be publishing an API in the very next release of the ISB, because one of the things we had is a lot of customers that said, this is great. You've got this really high performance engine, but we already have things like workload managers and other scripts that we've come to rely on. But we'd love to take advantage of the performance aspects of the product. So we've gone ahead and done that. It'll be very similar for the HSM components as well. And I don't think I completely answered your last question about the differences about it. The ISB is more about workflow at the job level, moving data in quickly and moving it out quickly. Things that typically are, different than what static HSM tends to focus on.
Right, right. And so, Bryan, has this workflow kind of focus, is that what's driving your development moving forward? Is that what the customers are looking for?
Yeah, they're looking for both. So as Lustre has gained sort of mainstream acceptance and is starting to get its foothold within the commercial space, people are looking for really two things. They want the ability to deploy these kind of storage solutions quickly, easily, and manage them, and that's what drives the TerraOS development. But once they start to add, multiple applications and take advantage of that compute and storage resource that they now have available, how do they get the data and move it around? How do they optimize the workflows so they can get the full utilization out of those valuable resources? This is really sort of the next generation, I think, in this space that our customers have really come to us and said, great, you solved this problem for me, you get the speeds and feeds taken care of, now how do we make sure that I can take advantage of it to the maximum?
Well, terrific. Well, Bryan, that sounds really like a great path forward for Terascala. And I want to thank you once again for coming on the show today.
Well, it's been a pleasure, Rich. Thank you very much, and hope we can talk again soon.
You bet, you bet. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on high-performance computing.